Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions.
This particular paper is OCR November 2020, Paper 3, Foundation Tier.
Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it.
Question 1. 5 is a factor of 20. Write down another factor of 20. Okay, so when I find factors, I tend to do them in a little table like this. I start with 1. 1 goes with 20. 2 goes with 10. 3, no, 4, yeah, 4 goes with 5. So we've already got 5, it was already stated. So if you pick any of the others, then that is fine, isn't it? I'm going to go for 4. Part B says write down a multiple of 20. Well, multiple of 20 is any number in the 20 times table, so 20 would work, wouldn't it? You could have 40, 60, 100, and so on. Question 2, part A, complete the first 7 square numbers. So we got 1, which is 1 squared, 2 squared is 4, 3 squared is 9, 4 squared is 16. So the one missing there is 5 squared, isn't it? It's 25. Okay, part B says write the missing term in each sequence. 18, 16, 14, blankety blank, 10, 8. Now, with sequences, the first thing to really look at is the difference. From 18 to 16, we're subtracting 2. From 16 to 14, we're subtracting 2. You seen the pattern yet? I'm guessing we're subtracting 2 again. 14 subtract 2 would be 12. Just check that works. 12 subtract 2 is 10, so that does seem to work, doesn't it? So I think it's 12. And then something 14, 20, 26, 32, 38. Again, if we're going to look at the term to term rule, 14 to 20 is plus 6, 20 to 26 is plus 6, 26 to 32 is plus 6. So presumably our missing number at the front plus 6 is 14. In other words, 14 subtract 6 is going to give me that number there. It's going to be 8, isn't it? Okay. Question 3, Alex has a number game. He must put down tiles to make 2 calculations with the same number. Here is what Alex put down. So 2 minus 3 times 2 equals 3 minus 5. Is he correct? Show how you decide. Okay. Well, when we have more than one operation going on, we really need to use BIDMAS in order to work out which operations to do first. Here, I'm going to have to do the 3 times 2 on the left-hand side first, aren't I? Okay, so 2 minus 3 times 2 is actually the same thing as 2 minus 3 times 2, which is 6. Is that equal to 3 minus 5? Well, 2 minus 6 is negative 4, and 3 minus 5, well, that's negative 2, isn't it? So these two things are not equal to each other. So Alex is wrong. Because negative 4 does not equal to negative 2. Okay. Now there's quite a lot of lines there. You don't have to fill them all up, and actually you don't even have to use words. You know, this is a mathematical reasoning here. I haven't used any words at all really, but that's fine. You know, maths is a language, and in this case I think that is perfectly adequate for this question. Question 4. A teacher asked 9 of his pupils how many pets they have at home. Here are the results. He's got 1, 1, 1, 2, 3, 4, 5, 7, and 111. I hope that's not 111 cats or guinea pigs. That'd be a lot, wouldn't it? Maybe it's tadpoles or ants. I don't know what he keeps, but anyway, that's a lot of them. Work out the range of the 9 results. Now, range is simply highest value minus the lowest value in your data range. So I've got 111 as my highest and 1 is my lowest, giving me a range of 110. Now part B says the median of the 9 results is 3 and the mean is 15. We need to write down the mode. So the mode is the most frequently occurring, isn't it? Mode is most. And you can see I've got 3 ones in my data set. All the others are just single. So 1 is the most frequently occurring, so the mode is 1. Part 2 says the teacher wants to use a sensible average to summarize the results. Which average should he use and why? Well, it's definitely not the mean, is it? I mean, if you have a look at the mean is 15. We got 9 results and 8 of them are nowhere near 15. In fact, none of them are near 15, even 111, isn't it? What happens when you've got like an outlier like this big 115 on the end, 111 on the end? It kind of drags the mean up towards the top end, and you can see it's kind of dragged it beyond the 7, well beyond the 7, and kind of up towards 111. So the mean, having an outlier like that really distorts the results for mean. So mean would not be a good one. So it's either mode or median. I think you could probably make a case for either. I'm gonna say median in this case, and the reason for that is because it is unaffected by outliers. Okay. Question 5a. The curved surface of a solid is made from this flat shape. Write down the mathematical name of the solid. Well, if you took that rectangle and kind of curved it around, you're going to end up with a shape that looks like this, aren't you? Okay. In other words, that shape is a cylinder. Okay. This is the plan view of a different solid. Now, a plan view is like a top-down view. Looking at it from above, okay, write down the mathematical name of the solid. Well, if you're looking at that from above, then probably what you've got, it's not totally clear, but I think what you've got is probably one of these, isn't it? Okay, and it's a pyramid looked at from above, square-based pyramid. So I'm going to say it is a square-based pyramid. You could probably get away with pyramid, but I like to be precise. It's a square-based pyramid. Question 6a, work out 70% of 50. So I'm going to use the FOM triangle that I often use for percentages. Final, original, multiplier. Now in this case, which ones have we been given? We've been given 70%. Now that is the multiplier. Well, it would be if I put it as a decimal. 70% as a decimal is 0.7. Now I want to find 70% of 50. Now 50 is my original value, and I want to work out what the final value is after I've applied the percentage. So original is 50, and I want to find the final. So covering up the thing I want to find, which is the F, it tells me what to do with the other two things. O times M. So final equals original times multiplier, which is 50 times 0.7. Okay, so reaching for a calculator. 50 times 0.7. 50 times 0.7. That comes out to be 35. Okay, so 70% of 50 is 35. B. Beth multiplies a number by 3 and divides the answer by 10. by what fraction has the number been reduced? Okay, so Beth takes a number and she multiplies it by 3 and then she divides it by 10. So basically she's finding 3/10 of the number then, isn't it? So it's 3/10. I'm just going to leave it as 3/10. So when you multiply a number by 3/10, you'll be multiplying it by the numerator and dividing by the denominator, wouldn't you? So it's 3/10 of my number. B, find a fraction that is bigger than 3/7 and smaller than 4/7. Okay, so the easiest way to do these ones, 3/7 and 4/7. If I just take each of those and I double up the denominators and numerators of both, so find an equivalent fractions to those two, then 3/7 is equivalent to 6/14, and 4/7 is equivalent to 8/14, and then you can see you've got a gap in the middle that you can then fill, which is 7/14. Okay, so that's my answer then, isn't it? The fraction that is bigger than 3/7 and smaller than 4/7 is 7/14. Now 7/14, you could cancel that down to a half. It's actually a half, isn't it? But you don't need to. It doesn't say that you have to write it in the lowest form. So just a fraction is fine. Question 7. Point A is plotted at 4, -2 on this 1 centimeter grid. Okay, we can see it down there at 4 - 2. Now the question says, point A is a corner of a square with an area of 36 centimeters squared. The other coordinates of the square have integer coordinates and lie on the grid. Find the coordinates of the corner of the square that is diagonally opposite the point A. You may use the grid above to help you. Okay, so if it has got an area which is 36. Now, area of a square is length times length, or length squared, isn't it? Okay, so the length of this square, or the side of this square, is going to be the root of 36, which is equal to 6. Okay, so it's going to have size 6. So if I count up 1, 2, 3, 4, 5, 6 points above A, and 6 to the left, 1, 2, 3, 4, 5, 6, and then another one 6 up from there, then you can see I get a square. Okay, let's just draw that in. Okay, looks about right. So what is the corner that's opposite A? Well, it's this one over here, isn't it? That's the one that's opposite over A. And what's its coordinates? Well, if you can see, you're -2 to the left and 4 up. So its coordinates are -2, 4. So that's my answer. -2, 4. Question 8a. Joe walks every day. This week she walked an average of 2,300 steps a day. Next week she plans to increase this by 15%. Work out how many steps she plans to walk in total next week. Okay, so this is another percentage question, in this case a percentage increase. So I'm going to use my same triangle I used earlier. I like this triangle for percentage questions because basically you can use it for every percentage question there is, and it's just one method. So once you've learned it, you can do it for every percentage question. So final original multiplier. Now I need to go through the question and see if I can work out what each of those things are, at least 2 of them anyway. So this week she walked an average of 2,300 steps, and we want to work out what it is next week. So this 2,300 is going to be the original then, isn't it? And then if we want to work out the total for next week, then that's going to be the final. So we've been given the original. It's 2,300, and we want to find the final. Okay, so what happens next week? Okay, so try and use the tense of the question. What comes first, what comes second, to work out which is the original and which is the final. Okay, then multiplier. This is a percentage increase. With percentage increase questions, you always start with everything, which is 100%, and then you add on the percentage increase. If it's a decrease, you take it away. So that is equal to 115%, which is a decimal is 1.15, and that's going to be my multiplier then. It's the decimal version of that percentage. Okay, so I want the final, so that's the one I'm going to cover up again. So final equals original times multiplier. Multiplier, which is 2,300 times by 1.15. Okay, tappity tap into the calculator. 2,300 times by 1.15. That comes out to be 2,645. 2645. Okay, steps. Okay, I'm not quite finished yet, have I? I just reread the question. So she's doing 2,300 steps a day. Next week she plans to increase it by 15, so she's going to do 2,645. Just rereading the question, it says work out how many steps she plans to walk in total next week. Okay, so I almost missed that. So in total, well, there are 7 days in the week, aren't there? And 2,645 steps each day. So taking my total and times it by 7, that's 18,505. Okay. Oof, lucky, I almost missed that. Right, B. Joe buys a pair of walking boots for £63 in a sale. She saves 1/10 of the original price of the boots. Work out how much Joe saves. Okay, so here basically we just need to work out what 1/10 of 63 is, then, don't we? What is 1/10 of 63? She saves 1/10, so 1/10 of 63. I could type it into my calculator, but I know already it's 6.3. Now remember, this is money, so it should be 2 digits after the decimal point. Don't just write 6.3, you'll get it wrong. £6.30. Okay, so she saves £6.30. Question 9. Mia has knitted 3 left-handed gloves. 1 blue, 1 green, 1 red. And she has knitted 2 right-handed gloves, 1 green and 1 red. She chooses a left-handed glove and a right-handed glove at random to make a pair of gloves. Amir says, I have the probability of 2/3 of choosing a pair of gloves of the same colour, as there is a red pair and a green pair, and there are 3 colours. Is she correct? Show how you decide. Well, I think her thinking is wrong on this. I don't know what the probability is, but the way she's thinking it through, I don't think is correct. Okay, now, you know, if she'd balled the gloves up, so she had the blue one by itself, and then she kind of balled the 2 red ones together, and then she balled the 2 green ones together, then you've got like a 2 in 3 chances of picking the pair of gloves that have got like a left one and a right one, haven't you? But that's not what she's doing. What she's doing is she's picking one of the blue, red or green ones first, and then she's going on to pick either the red one or the green one second. Okay, so she's making 2 selections. Okay, and so the best way of modeling this, I think, is going to be using what we call a sample space. So a sample space looks like this. If I have my left choice over here and my right choice over here. So she's got 3 choices for the left. It's got blue, green and red. And we've got 2 choices for the right. We've got green and red. Okay, then inside my sample space here, I'm going to put a little cross or a tick depending on whether or not I've got a pair. Okay, so the first little cell in here, blue left, green right, that's not a pair, is it? So I'm going to put a little cross there. The next one along, I've got a green left, green right, that is a pair. And then I've got a red left, green right, that is not a pair. And in the next row, I've got a blue and a red, nope, that's not a pair. Green and red, nope. And I've got a red and red, that is a pair. Okay, so if you have a look here, then I've got 1, 2, 3, 4, 5, 6 outcomes, of which 2 are a pair. So I'm going to say Mia is wrong. And why is she wrong? Because the probability of getting a pair is going to be 2 out of 6, which is 1/3, and not 2/3. Okay, so again, my reasoning here doesn't have to be words. it can be maths. And actually in this case, as a maths paper, you know, maths is a pretty good thing to be writing down. Right, let's move on. Question 10. Sandip is going on holiday. She wants to change £400 into euros. Bank A will change her £400 into 452 euros. Bank B changed £250 into 280 euros for Sandeep's friend. It will use the same rate to change Sandeep's £400 into euros. At which bank will Sandeep receive the most euros, and by how many? Show your working. Okay, so we know what's going on in Bank A. We just really need to work out what's going on in Bank B, don't we? Now, Sandeep's friend took £250 and she changed it into 280. So we can use those two figures there, that one and that one, to work out the exchange rate. So the exchange rate is going to be, well, let's take the 280 and divide it by 250, and that will tell me how many euros I'm going to get for each pound. Okay, so the exchange rate is 280 divided by 250. That comes out to be 1.12, which is basically £1 then is going to get you €1.12. Okay, so then if I then have £400 to change, I'm going to take my €1 and 1.12 euros, and I'm going to times it by 400, and that's going to give me 448. Okay, so 448 euros from Bank B. Now we got 452 from Bank A. So Bank A is going to give her the most. Okay, by how much? Difference is going to be what she got in Bank A, 452, minus what she gets from Bank B, 448, and that comes out to be 4. So Sandeep received €4 more. Okay, might buy her a, you know, drink at the bar or something. Question 11. I've got 5 lots of 2x plus 1 plus c lots of x plus d, and we're told that's equal to 12x minus 1. And from that we need to work out the value of c and the value of d. Okay, so I've got brackets here, single brackets, which I can multiply out by multiplying everything inside the bracket with everything outside the bracket. Okay, so the left hand side then is going to be 5 lots of 2x, which is 10x, plus 5 lots of 1, which is 5, plus c lots of x, which is cx, plus c lots of d, which is cd. And we're told that's equal to 12x minus 1. Okay, so collecting the terms in x together, I'm just going to group them up first. So I've got 10x and cx over here, and then the number terms, I've got 5 and I've got cd. Okay, so terms to do with x and terms not to do with x, and we're told that's 12x minus 1. Okay, I'm just going to factorize out the x out of these first two terms. So I've got 10 plus c lots of x plus 5 plus cd. Now the reason I'm doing that is that I want to do something called comparing coefficients. Now if these two things are the same, then the number of x's we've got here is going to be the same as the number of x's I've got over here. And the things that have not got x in over here are going to have to be the same as the things that have not got x in over here. Okay, so from that I can kind of extract and form two separate equations. So equating the two yellow bits there then, 10 plus c must be equal to 12, and equating the green bits, I can see that 5 plus cd must be equal to minus 1. Okay, now I'm going to start with the yellow one. 10 plus c is equal to 12 because it's only got one unknown in there. If I take 10 away from both sides, okay, they're going to cancel. It's going to leave me with c on the left, and then 12 take away 10, that's 2. So if c is equal to 2, I can then sub that into my second equation here. So 5 plus 2d then is equal to minus 1. Taking 5 away from both sides, subtract 5, subtract 5. That's going to leave them with 2d on that side. 2d is equal to negative 1, take away 5 is negative 6. Okay, and then dividing both sides by 2, that's going to cancel with that, leaving with d. D is equal to negative 3. Okay, so C is 2, D is negative 3. Question 12a, complete the power of 2 for each statement by writing the missing value in the box. So this is a law of indices questions. 2 to the power 3 times 2 to the power 3. We got two numbers with the same base, 2 and 2. So we're just going to add these numbers up here. So we're going to add the 3 and the 3 together. That's going to give me 6. 1 over 32 is equal to 2 to the power what? Well, immediately I can see it's going to be a negative index, because a negative index is like 1 over the positive index, and I need to work out 2 to the power what is 32. So just going through powers of 2, just timesing by 2 and counting up, I've got 2, 4, 8, 16, 32. So that's power 1, 2, 3, 4, 5. So 32 is 2 to the power 5, but I've got 1 over 32, so that's going to be 2 to the power of negative 5. Okay. 2 times 2 to the power of y is equal to 1. Okay, what is the value of y? Okay, well, 2 times 2 to the y, that's the same thing as 2 to the 1 times 2 to the y. Okay, in other words, I've got 2 to the power, if I add those two things together, I'm going to get 2 to the power of y plus 1, and that is equal to 1. Okay, now any number to the power of 0 is 1, so that tells me, so 2 to the 0 is 1, so again, like that there, that y plus 1 must be the same thing as 0. So I'm going to say that y plus 1 must be 0, and then so y is going to be minus 1. Okay, yeah, that's what it is. So y must be negative 1. And that makes sense, because if y was negative 1, then what I'd have was 2 times 2 to the negative 1, which is half. 2 times a half, that's 1, isn't it? So that does make sense. Question 13a, the mass of flour used in a recipe doubles as the number of biscuits made doubles. On the axis below, sketch a graph to show this relationship. Okay, so this is just a direct proportional relationship, isn't it? So I can simply show that on a graph as a kind of a diagonal line passing through the origin. Now obviously if it's doubling, then the gradient is going to be 2, but this is just a sketch, so I don't really need to show the gradient. If there was a grid paper on it, you know, with squares, and I'd go 1 along 2 up, 1 along 2 up. But it isn't, it's just a sketch. There is no axes shown, there's no numbers on the axes. So any old diagonal line through the origin will be fine. Part B says, here are some of the ingredients for a recipe to make 10 biscuits. To make 10 biscuits, 120 grams of butter is required and 100 grams of sugar. Jane followed the recipe and used 432 grams of butter. All of the sugar used came from a new 2 kilogram bag. Find the number of biscuits that she made. Okay, well, if she can make 10 biscuits, she can make 10 biscuits, can't she, with 120 grams of butter. So if I did like a ratio of biscuits to butter, the ratio would be 10 biscuits requires 120 grams of butter there, wouldn't it? So then one biscuit is going to be a tenth of that. It's going to be 12 grams. Okay, so if then the amount of butter is 432 grams, how many times does that go into that? I'm just going to work it out. Let's do that in red. So how many times does 12 go into 432? I'm just going to divide one by the other. So 432 divided by 12, that goes in 36 times. So I'm kind of scaling up my biscuit recipe 36 times, which means that is going to be making 36 biscuits. So that should be 36 there. So find the number of biscuits she made. I think that's 36. Now I'm a bit confused because I'm not sure what this stuff to do with the sugar comes from. Oh, maybe that's in the second part of the question, because we haven't used, I was a bit in and ahhing if I got that one right, because I haven't used this bit of info. It seemed a bit weird that they would give it me as a red herring, so I actually just think it's used in part 2. So find the mass of sugar in grams that Jane has left in the bag. Okay, so if she's made 36 biscuits, I'm gonna do something similar here. I'm gonna add another bit to my ratio here. So I'm gonna add kind of like a ... sugar, and I know for 10 biscuits that's 100 grams of sugar. So for 1 biscuit divided by 10 is 10 grams of sugar. So for 36 biscuits times by 36, that's going to be 360 grams of sugar. Okay, so then she requires 360 grams of sugar. If it's a 2 kilogram bag, 2 kg, and that's 2,000 grams, isn't it? So remaining is going to be that 2,000 gram bag she started with, subtract the 360 grams of sugar that she used. So 2,000 take away 360, that's 1,640 remaining. I'm just going to write that in grams so it's clear. Oh yeah, ask for in grams anyway. Okay, so that's good. So 1,640 grams remaining. A travel agent records the duration and cost of 15 flights he sold on one day. The data for the first 13 flights are plotted on the scatter diagram. Now it says part A, the data for the final 2 flights is, and then I've got the cost and duration of 2 more flights. I need to plot these on the scatter diagram. So the first one is 210 and 130. So I need to find 210 on the graph and 130 on the graph. Read up from 210. Read across from 130 and plot my point. So I think it's going to be about there then. Okay. And then I've got a second point, which is 1 hour 40 minutes against 80 pounds. Okay, now that's in a different form, isn't it, that one? Let me just convert that into minutes first, because the bottom scale is in minutes. So an hour and 40 minutes, that's 100 minutes, isn't it? Okay, so that's 100 against 80. So 100 against 80 is here in the middle. Okay, so that seems to be everything. So we've done that part. Part B says the cost of one of the 15 flights has been discounted in a sale. Circle the most likely flight on the diagram. Okay, so all the rest kind of line in a fairly much a straight line, but we've got this one down here, haven't we, which is kind of sitting all on its own. That one is our outlier, so I assume that one's the one that's been discounted. So it should, you know, all the ones at about 210 have been up at the cost of about 130, haven't they? So that one is significantly lower, so I think that's the one that's been discounted. Draw a line of best fit on your diagram. Okay, we need to get a ruler out. You can see the points are kind of marching up in this direction. It's positive correlation. Just try and get your ruler so you've got about a similar number of points on either side of the line, kind of following your main line up. Doesn't have to go through the origin, and actually if you force it through, you can get marked down for that. Okay, mine goes something like that. Okay, and then use your line of best fit to estimate the duration of a flight costing £90. Okay, so how long would a flight costing £90 be? Okay, what I'm going to do is I'm going to look up £90 on my scale, which is about here, and then I'm going to read across to my line of best fit and then change directions and read down from there. Okay. Mine comes out to be somewhere between the first and the second line there. Now there are 5 divisions between 100 and 150, so each one of those is going to be worth 10. So I think that's pointing at about 105, something like that, 105, 110, something like that. Now yours might not be exactly the same because you might have drawn your line of best fit slightly differently. Don't worry about that. As long as you're within half a square of your own mark on your own diagram, then that's fine. Finally, explain why the travel agent should not use his records to estimate the cost of a 7-hour flight. What we just did there is an example of interpolation, because the value we looked up is between our kind of known points. We know from here to here, don't we? We all know this area here. So looking up within that range is fine. It's called interpolation. Now, when you're trying to look up beyond the edge of this line, which a 7-hour flight would be, what's that, 350 minutes? That's kind of beyond our last point. We call that extrapolation, and it's not that reliable, or we have no evidence to say that it's going to be following the same pattern. Okay, so this would be extrapolation, and is unreliable. Okay. Question 15. A rectangle has 3 times as long. Question 15. A rectangle is 3 times as long as it is wide. It has a perimeter of 44 centimeters. Find the length of the rectangle. Okay, now actually, I don't know if you noticed, but this is an algebra question. You probably thought it's just a geometry, shape and space question, but no, it's actually algebra. I'll show you why. It's because we're given things relative to each other here. We don't know the actual values. You have to kind of work backwards in order to find the length and the width. Okay, so we're told it's a rectangle, and we're told that the length is 3 times as long as it is wide. Now, I don't know how long it is wide. If I did, I could just take that amount and times it by 3 and find the length, but I don't know. So in that case, I'm going to just say for now that is equal to x. So then the length of it is going to be 3 times that. It's going to be 3x. Okay? So then the perimeter of my rectangle is going to be the 3x plus the x plus the 3x plus the x, then, isn't it? Okay? So it's going to be 3x plus x plus 3x plus x, just walking around my shape. And then that, we know, is equal to 44 centimeters. Okay? So just collecting up like terms, 3x plus x plus 3x plus x, that is the same thing as 8x. Got 8 x's all together. That's equal to 44. So then what is x? So we can find x basically by just dividing both sides by 8. Divide by 8, divide by 8. So 8 goes into 8x x times. And 44, 8s into 44 go 5.5, don't they? 5.5. Okay, so x is 5.5. So that is the width then, isn't it? That's 5.5. Now the question asks for the length, which is this one over here. Okay, so 3 lots of 5.5, that is 16.5 then, isn't it? So the length is 16.5. 16.5 centimeters. Solve 3x plus 4 is less than 19. Show your solution on the number line. Okay, so inequalities we can solve in exactly the same way as we solve equations, if we're careful. So if this was an equation, if that sign in the middle was an equal sign, I'd be looking to isolate x, get by itself. So I'm going to be subtracting 4 from both sides. That's going to give me 3x is less than, that's going to cancel that, isn't it? And I'm going to be left with 15 on the other side. So 3x is less than 15. And then dividing both sides by 3. That's going to cancel with that. And I'm going to be left with x is less than 5. Okay? Now I can show that on the number line by putting an open circle above 5. Now, if it was less than or equal to, I would fill that circle in, okay? Because the 0.5 would be part of my solution. But because it's strictly less than, I use an open circle on 5, okay? And then I'm going to point at all the values less than 5. So I'm going to draw a line with my ruler going off to the left from that point. Okay, so and carrying on in that direction. Question 17, the area of a triangle is equal to the area of the trapezium. Calculate the height h of the trapezium. Okay, so we need to know the area formulas for these various shapes and then use them, I think. One forward, one backwards. Okay, let's start with the triangle. The area of a triangle, do you know the formula for that? It's just half base times height, isn't it? Where base and height are two side lengths at right angles to each other. Okay, so the right angle, sorry, it got reproduced quite poorly, is down here. So I'm going to use my base as 9 there, and my height as the 8. Okay, so then subbing that into the formula, that's half times 9 times 8. Half 8 is 4, 4 9s are 36. So that's 36 centimeters squared. Okay, so that means if they are the same, then this trapezium has an area of 36 centimeters squared as well. We know the two parallel sides. This is parallel to this one, isn't it? Okay. What we want to know is the distance between the top and the bottom of this this trapezium. So the area of a trapezium formula, that is half a plus b times h. Okay, it looks like a complicated formula, but basically half a plus b is just finding the average of your two parallel sides, this one and this one. You add them together and you divide by 2, and then you multiply it by the distance between them, which is h. Okay, so we know the area already. It's 36. We know a is 12. We know b is 20. What we don't know is h. Okay, well, that's what we need to find. Okay, so let's just think this through. 12 plus 20. What's 12 plus 20? That's 32. So half times 32 times h is equal to 36. Half of 32 is 16. So 16h equals 36. So then what's h then? H is going to be, well, let's divide both sides by 16. 36 is in 16 is into 36. 36 divided by 16. So that comes out to be 2.25. Okay. Question 18. Here is a right angle triangle. Use trigonometry to work out the value of x. Okay, so with right angle triangles, if I want to use trigonometry, I'm going to be first thinking about SOHCAHTOA, or whichever other mnemonic you use to remember which trigonometric ratio you're going to use. Okay, so and then I'm going to label up my side. So my angle's down here, it's 34, and then I'm going to label up the sides of my triangle relative to that. Well, this one is always h, the one opposite the right angle is always the hypotenuse. Then this one over here, look, is the opposite because it's opposite the angle, and this one down here is the adjacent because it's adjacent or next to the angle. Okay, so I've been given the adjacent, which is 8. I want to find the opposite, which is x. Okay, so which ratio has got the adjacent in it and the opposite? Okay, well, it's not SO because it's got a h in it. I've got a h, I wrote h over here, but I don't know what it is and I don't want to find it. So any of the ratios with h in are not the ones that I want. I want the TOA, I want the one that has got the adjacent in it and the opposite, which is this one here. Okay, so once I know that I'm using tan, I'm going to write down the full trigonometric ratio, which is tan theta equals the opposite over the adjacent. Okay, once I've got that written down, it's just a simple matter of plugging in all the values from my diagram into the formula I've got over here. So tan theta, theta is the angle, so tan 34. Some people try and remember these ratios without this. They just remember tan is opposite over adjacent, and then they get the questions wrong because they don't know where to stick the angle. Okay, so just try and remember it is tan theta, sine theta, cos theta, just so you remember that that is where the angle goes. So tan theta is equal to the opposite, which is x, divided by the adjacent, which is 8. Okay, so you want to get x by itself, so to do that we're just going to multiply both sides by 8. Okay, that one's going to cancel with that, leaving me with x on the right, and that's going to be equal to tan 34. So now we've just reached for the calculator. Just double check your calculator has got a little D at the top and not an R or anything else like that. So it's in degrees. 8 tan 34 comes out to be 5.396. So x is equal to 5.39. I'm just going to round it up to 5.40. 5.40 what centimeters? Okay, so 5.4 or 5.040 centimeters. Work out the size of the exterior angle of a regular 12-sided polygon. Well, that's easy. Each exterior angle is going to be 360 for any polygon. It's 360 divided by n, which is where n is the number of sides. So in this case, it's going to be 360 divided by 12 because it's a 12-sided polygon. 12 goes into 36 3 times. That's 30 then, isn't it? So each exterior angle is going to be 30 degrees. Okay, and then use your answer to part A to write down the size of the interior angle. Exterior angles and interior angles make lie in a straight line, don't they? So this is the exterior angle. This is the interior angle. So they lie in a straight line, so they add up to 180 degrees. So each interior angle is going to be 180 minus the exterior angle, which is 30, which gives you 150 degrees. 6. A truck is used to transport some wood panels. Each wood panel is a cuboid measuring 2.4 meters by 1.2 meters by 1.8 centimeters. It's in bold. Obviously, it's something that students often miss. The density of each wood panel is 750 kilograms per cubic meter. The truck can carry 12 tons of these wood panels. Calculate the maximum number of wood panels that the truck can carry. Show how you decide. Okay. So I think what we need to do is work out the volume of these panels first off. So the measurements are here, aren't they? Okay, so let's work out the volume first. Now they're a cuboid, so the volume of a cuboid is just simply length times width times height, isn't it? Okay, now the length is 2.4, the width is 1.2, and the height is 1.8 centimeters, which in meters is 0.018 then, isn't it? Because there are 100 centimeters in a meter. So 1 centimeter is going to be 0.01 of a meter. Okay, so that's what I've got. What's that then? 2.4 times 1.2, 2.4 times 1.2 times 0.018. That means that each panel is 0.05184 of a cubic meter. Okay, right, so then the density of each wood panel is 750 kilograms per cubic meter. So then the mass of these the mass is going to be, density equals mass over volume, isn't it? So mass is going to be density multiplied by volume, which is going to be 750 kilograms per cubic meter times my 0.05184 cubic meters. So 750 times by our last answer comes out to be 38.88. So they weigh 38.88. What's the units? It's going to be in kilograms, isn't it? Kilograms per panel then, isn't it? 38 kilograms, 38, almost 39 kilograms per panel. Okay, so the truck can carry 15 tons. Now this is a metric ton when it's written like this, and a metric ton is 1,000 kilograms. So this is actually 15,000 kilograms, isn't it? Okay, so how many panels that weigh 38.88 fit into the carrying capacity of the truck? So number of panels is going to be the 15,000 capacity of the van divided by the weight of one panel then, isn't it? Okay, what's that then? 15,000 divided by 38.88. That comes out to be 385.8. Now, if I should really round up, shouldn't I? Because it's closer to 386. But actually, then that would be too heavy. That would exceed the carrying capacity of the truck. So in this case, even though 0.8 is closer to, you know, the next number up, I'm going to round down. So that's 300 and well, let's write it down, 385.8, and we're going to say therefore 385 panels can be carried. Question 7, vectors A and 4B are drawn on the grid. And then part A says, write vector A as a column vector. Okay, so column vectors are written in the form x over y, where x is the distance from one end of the vector to the other in the direction of x. So you can see that's 4 units in that direction. And then in the direction of y, which is, it's actually, y is how many units up it is, and this is actually 2 units down, so this is considered to be -2. So the column vector is going to be 4 units in the direction of x and -2 units in the direction of y. And then part B says, find the vector B as a column vector. Okay, now we've actually got 4B here. It doesn't actually fit nicely on the grid. I'm just gonna work out what 4B is first, and then I'm going to divide it by 4, I think. So 4B, that is equal to, I'm going to do the same thing. How many units in the direction of x and how many units in the direction of y do we need to go? Well, this is 1, 2, 3, 4 units in this direction, and 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. You see, they're being a bit cruel to us here. So that's going to be 4, 9 then. So the vector B by itself is going to be a quarter of that then. So it's going to be a quarter of 4, 9. Which, a quarter of 4 is just 1, isn't it? So the top number is 1. Now the bottom number is going to be 9 divided by 4. Which is, I'm just going to write it as 9/4 actually. So it's 9/4. 1 and 9/4. Question 22a, complete the table for y equals x squared minus x. Okay, now with these tables that you need to complete, the easiest way is to use the table mode on your calculator if you've got a Casio. If you don't have a Casio, you really want to get one of these because they've got lots of features that are very handy for your exam. That you miss out on otherwise. So if you tap on mode and go to table, then you get f of x is equal to displayed on your screen. So it uses a slightly different notation. F of x is the same thing as y basically. So y is equal to, and then we just type in the bit on the other side of the equal sign, x squared minus x. Now to type in the x, you need to press the alpha key and then the x here is above the bracket. So x squared minus and then alpha x again. Okay, so x squared minus x. Press enter. You're going to get g of x appear. Now we've only got one function to type in this time, so we can leave that one blank for now. And then press enter again. Then the start value is going to be, well, I would go for, either look at the table. If it gives you an x value, fine. If it doesn't, then what you can do is just look at the x-axis on your diagram and then pick out the number on the far left and the far right as your start and end values. So I'm going to be starting at -2, I'm going to be ending at 3. Now the step is what we're going up in this case. You can see here we're going up in ones, so we're going to go up in ones. And then press enter, you can see I'm going to get a nice table displayed with all the values in that I need. Okay, so on my table then, the first box is -2 goes with 6. So I'm going to put in my -2 in there. And then I've got -1 goes with 2. So -1 goes with 2. 0 goes with 0, which matches. 1 goes with 0. 0. 2 goes with 2. and 3 goes with 6, so the rest all matches. Okay. So we filled out the table, and that was really easy. Just make sure you use the table because it does make life a whole lot easier. Part B, the graph of y equals x plus 1 is shown on the grid. It's already drawn. On the same grid, use part A to draw the graph of y is equal to x squared minus x for the values of x from -2 to 3. So basically, we just need to plot those points, don't we? Okay. So -2 goes with 6. -2 goes with 6, so that's a point there. -1 goes with 2. 0 goes with 0. 1 goes with 1. 2 goes with 2. And 3 goes with 6. Okay. Now, this is a quadratic curve. It has a nice smooth parabola between the points. That's what you're going to be drawing on this shape. Okay, so it's a curving thing. Should be symmetrical on both sides. Now, it doesn't have a flat bottom, so it will dip below the axes between 0 and 1 and then start coming back up again. Okay. Now try and do a smooth line. It doesn't matter if it's a little bit wobbly, okay, but what you shouldn't have is feathering, so not multiple lines, and you need to try and skewer each of your points. So do try and go through each of the points you plotted. Okay, so a little bit of wibble is not important, but you know, nailing the points and not doing multiple lines between points is that's what you're going to actually lose mark for. Now the last point says write down the x coordinates of the point where the two graphs cross. Now you can see they cross in two places. They cross here, look, and here. Now we want the x value, so if I just get a ruler and I read down to the axes, it's probably the easiest thing. Over here. Okay, so the first one looks slightly to the right of like a -1/2, but only ever slightly, and so I'm just going to leave it as -0.5, and then the other one is slightly to the left of 2.5, but not enough for me to change the value again, so I'm just going to put in -0.5 and 2.5, so -0.5 and 2.5. Okay. And I think we're done. Question 23. The probability that Adam cycles to school or walks to school depends on the weather. On any day, the probability that the weather is wet is 0.4. When the weather is wet, the probability that he cycles to school is 0.3. And when the weather is dry, the probability that he cycles to school is 0.8. So here we've got like a dependent probability problem here, where each part of the probability tree below is going to have different numbers on it. And you can see that clearly on the diagram. Okay, so part A says, work out the probability that it is dry and Adam walks to school. Okay, so dry and Adam walks. Okay, that's dry walks. It's that route there, isn't it? Okay, so the probability of dry walk is the probability of dry, 0.6, times by the probability of walk, 0.2. We just need to kind of multiply down that diagonal. 0.6 times 0.2, that comes out to be 3/25. I'm just going to, should I write as a decimal? That comes out to be 0.12. Okay. Then part B, so 0.12. Part B says, what's the probability that Adam cycles to school? Okay. So Adam's cycling to school then. There are two possible routes through here, isn't it? So either it's wet and he cycles, or it's dry and he cycles. So the probability of cycles is probability of wet cycle plus probability of dry cycle. Okay, now probability of wet cycle is going to be the probability of wet, 0.4, times the probability of cycle, 0.3. And the probability of dry cycle then is going to be probability of dry, 0.6, times the probability of cycle, 0.8. Okay, so what's that then? So 0.4 times 0.3 that's 0.12 again, plus 0.6 times 0.8, 0.6 times 0.8, that's 0.48. So add those together, plus 0.12, that comes to 0.6, doesn't it? So that's going to be equal to 0.6. So that's my answer then, 0.6.
You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.